So we'll solve some numerical on this clutch friction. As you can see in this example, it has asked to find out the maximum, minimum and average pressure when the axial force is 3 kilonewton. Okay, and this is the case of a single plate clutch. Okay. So here given data are R1 is given 80 mm outer radius, R2 is given 40 mm, axial force, that is the W, or in some books they used to write F, is given 3 into 10 to the power 3 Newton. Okay. Now the formula to find out the maximum pressure, and we know that the maximum pressure will be at the inner radius. Okay, and this relation will be W is equal to 2 pi P. P is the intensity of pressure, R2 into R1 minus R2. So here W is given 3 into 10 to the 3, 2 pi into P we need to find out. R2 is given 0.04 in meter I am expressing. R1 is 0.08 minus 0.04. So when you solve this, you will find P as your 298.4 kilonewton per meter square. Okay, this is the maximum pressure. Then minimum pressure. This minimum pressure will be at the outer radius. Okay, so we'll use this relation W is equal to 2 pi P, the intensity of pressure, into R1, as it will be at the outer radius, into R1 minus R2. So we have 3 into 10 to the power 3 is equal to 2 pi into P into R1 is 0.08 into 0.08 minus 0.04. Okay. So if you solve this, you will find this intensity of pressure, minimum intense pressure, is 149.2 kilonewton per meter square. Okay, and then comes your average pressure. Average pressure. Formula for average pressure is equal to total axial force or axial thrust divided by your cross sectional area. Cross sectional area. Okay, so this will be equal to your 3 into 10 to the 3 divided by 5 times of 0.08 square, that is your R1 square, minus R2 square is 0.04 square. So this will be equal to 198.9 kilonewton per meter square. Okay. Next, another important problem is so let's say this is example 2. So here in this question it is saying a single plate clutch required to transmit 8 kilowatt at 1000 rpm. The axial pressure is limited to 70 kilonewton per meter square, and the mean radius of the plate is 4.5 times the radial width of the friction surface, and if both sides of the plate are effective, that means n is equal to 2 and the coefficient of friction is 0.25, find out R2 and R1 and the mean radius and width of the friction lining. Okay, this is one of the important problem. Now in this case the given data are P is given power 8 kilowatt, mu is given 0.25, n is given rpm 1000 rpm, P intensity of pressure is 70 kilonewton per meter square. Okay, now assuming uniform where your mean radius of friction surface R is equal to R1 plus R2 by 2. Okay, and this is 4.5 times of the radial width, so it will be 4.5 into R1 minus R2, because here radial width means this is clutch plate area and this is the friction lining. Okay, if you see from the side view, and this up to this is your R1 and this is your R2. So if you go radially, so this distance will be R1 minus R2. So mean radius, that is R1 plus R2 by 2, is 4.5 times of R1 minus R2. So from this we can get a relation that R1 plus R2 is 9 times R1 minus R2. Okay, or we can say that your 8 R1 is equal to 10 R2, or R1 is 1.25 times of R2. Okay, then why you are using this uniform wire theory? Because in case of power transmission, it is safe from design point of view, to use this uniform wire theory, So we have power is equal to T omega, or you can say torque transmitted will be P by omega, and power is given 8 kilowatt. So 8 into 10 to the 3 divided by 2 pi into n is 1000 by 60. Okay, so we have 8 into 10 to the power 3 into 60 divided by 2 pi into 1000. So this get cancelled out, this becomes 30. So your T will be 76.39 Newton meter. Okay, we got the torque. Now this torque according to uniform wear theory is 1 by 2 mu w r1 plus r2. Okay, we don't know this w, okay, but we know that intensity of pressure is w by pi r1 square minus r2 square. That means your w will be p into pi times of 1.25 r2 square minus r2 square. Okay, now substitute this value of w here in this equation. So you'll have this T is equal to half so we know that the pressure will be minimum at the outer radius, so we will use this relation that W is equal to 2 pi into P R1 minus R2. Okay, now use this relation here, so we will have T is equal to half mu times into 2 pi into P P into R1, that is 0.08 into 0.08 minus 0.04 into R1 plus R2, so 0.08 plus 0.04, okay, into n, because both sides of the glass plate are effective, so we will multiply 2 here. Okay, now if you solve this, we will have this relation that 76.39 is equal to 61,850 R2 Q. Okay, So upon further solving, you'll get R2 value as 0.1073 meter, and then your R1 will be 1.25 times of R2. So 1.25 multiply with 0.1073, so it will be 0.1341 meter. Now the mean radius will be is 4.5 times of R1 minus R2, so it is 4.5, 0.1341 minus 0.1073, so this will be 0.1207 meter. Okay, then second bit was to find out the width of the friction lining. Okay, width of friction lining. Now this will be equal to R1 minus R2 simply. Okay, or you can say it is equal to mean radius divided by 4.5, whatever you can use. So this will be equal to 0.0268 meter. Okay, so you can find out in this way. Okay, another question, suppose it is given that let's say this is example 3. So here this question, it is telling a single plate clutch transmits 25 kilowatt at 900 rpm. The maximum pressure intensity is 85 kilonewton per meter square. Outer radius is 360 mm and both sides of the plate are effective. Mu is given 0.25. Determine the R2, okay, and that is the inner diameter of the plate, and axial force to engage the clutch to find out W. Okay, so here given data are P is 25 kilowatt, N is given 900 rpm, intensity of pressure is 85 into 10 to the power 3 Newton per meter square. Outer diameter is given. Okay, that means D1 is given 360 mm, that is R1 is given 180 mm, and N is 2 because both sides are effective. Mu is 0.25. Okay, now we have P is equal to T dot omega, so 25,000 is equal to T dot 2 pi into 900 divided by 60. Okay, if you solve this, your T will be 265.26 Newton meter. 26 Newton meter. Okay. Now we have this T is half mu W R1 plus R2 into N, considering uniform wear theory. Okay. So we have this 265.26 is equal to half into mu into W. Instead of W we can write 2 pi into P, okay, into R2, okay, R2 into R1 minus R2 into R1 plus R2 into 2. One correction here, this will be R1, okay, so it will be 0.04. okay. So answer will be same. Okay, by mistake I have written here, please check it out. Okay, now if you solve this, you will get T as your R2 you will get as 131.5 mm. Okay, so the inner diameter will be double of this. Okay, now second bit was to find out W. So to find out W, you will use this relation that W is equal to 2 pi into P into R2 into R1 minus R2 into N. Okay, so substitute the value 2 pi into 85 kilonewton per meter square, so 85,000 into R2 is 0.1315 in meter, then R1 is 0.18 minus 0.1315 into 2, so we'll get W as 6812. 6812 Newton. Okay, so likewise you have to solve the numerical related to clutch friction.